So in this video I will show you an example of addition of two forces, or you can say two vectors. Similarly, you can add more than two forces or two vectors. So for this you need to just know how to find out the components of a vector. So if you don't know, just go back my previous video where I showed how to find the component of a vector or vector resolution. So here are two forces of 2 Newton and 3 Newton acting on a body at angle uh, 30 and 45 with x-axis respectively. So the 2 Newton so I shown in diagram, the F1 is 2 Newton force which acts at 30 degree with x-axis. The other is F2 is 3 Newton which acts as which acts at angle 45 with the x-axis. So always remember, it's a good idea to find an angle made with the same axis, either that may be x or y, it does not matter. But if you find the angle both made with the same axis, it's easy to in your calculation. So let's find the x component. Let the resultant force would be F, which is the resultant force of F1 plus F2. Now you need to find the x component of this force. The resultant force is the x component of F1 force plus the x components of F2 force. So the x component of F1 force is 2 times cos 30 plus 3 times cos 45. If you calculate this one, you will get around 3.85 newtons. So I'm just taking up to 2 decimals. Similarly, you need to find the y component. This is the sum of y component of first force plus the y component of second force. So this is simply 2 times sine 30 plus 3 times sine 45. This will give me a value let me calculate this one. And this will give me 3.12 newtons. So I find here I calculated the x components and y components. Now the magnitude of the force F, simply I will denote this by F without arrow. That means its magnitude. This is the square of x components and the square of y components. So if you square 3.85 plus 3.12 square and take square root, you will get some number value. Let me figure out what that number. It's 3.85 square plus 3.12 square, and this is let me take the square root of my answer. No, square root of the answer. Okay, this will give me 4.96 newton. So this is the force. The 4.96 newton is the resultant force of these two forces, but we don't know where is acting, I mean the angle made with the x-axis. Let this force make an angle of an angle of, suppose I consider this force make an angle of uh, theta. This is the F force. This is make an angle theta, and this is its x component f of x, and you can consider this is at y component f of y. So the tan theta is simply fy divided by fx. So again, if you plug in the values of fy, and fy is 3.12 and 3.85, and if you take inverse of this value, tan inverse of this 3.12 and 3.85, you will get a certain angle. Let me calculate that angle. It's tan arc or tan inverse of 3.12 divided by 3.85. So this will give me an angle of 39 degree, around 39, yeah, around 39 degree. So our resultant vector have a magnitude 4.96, and it's acting at angle. So this is our resultant vector, whose magnitude is 4.96, and it's acting an angle at angle 39 degree with the x-axis. So here is our body. This is in Newton, so you need to take care of the units of the force. It's Newton. So this is the resultant force of the force 2 Newton and 3 Newton. It's not a 5 Newton, it's less than 5 Newton. So it depends on the angle, so can have a different value.